Hi everybody. These are the worked out solutions to the review sheet 4145 number 2. So I just worked these out myself, so I'm going to kind of keep an eye on that and check my work as I go before I make copies for you. So that's what I'll be looking at as I go through here. But here we go. Problem number 1. 7 pi over 6, we're going to change it to degrees. We've done this a zillion times. Pi is 180, divided by 6 is 30, times 7 is 210. So our answer is 210 degrees. 270, we're going to change that to radians. So we'll say pi over 180 equals x over 270. That's our proportion that we set up every single time we need to change a degree measure into a radian measure. Pi radians is 180 degrees. How many radians is 270 degrees? So we'll cross multiply. So we have 270 pi equal to 180x. So x equals 270 pi over 180, which does reduce to 3 pi over 2. Now we want to use our calculators because we're going to find degrees, minutes, seconds for 119.765 degrees. So we'll get out our calculators and we will literally type in 119.765. Then we will go to our second angle menu, which is the apps button, second angle. We'll click down to DMS, degrees, minutes, seconds, and that tells us, we have to hit enter a couple times, that tells us 119 degrees, 45 minutes, and 54 seconds. And then we will go to this problem, which is exactly the opposite. We will put in 153, and then our degree mark, which comes from the angle menu again. So second angle, degrees, the very first one, 18, second angle, click down to the minute mark, and then 12. Now, I'd love to go back into my second angle menu, but you know what? The seconds aren't there, are they? They're clear down here above the plus sign. So I have to press alpha plus. That gives me my seconds mark. And that one I'm going to need to round off. It's 153.303 degrees. If you're still having trouble with that, you will want to lean over and ask your neighbor. Because most of us know how to do that pretty well, so we can help each other with that one. Okay, now we're going to find the length of the arc. So we have a circle with a radius of 10 and a central angle of 2.1 radians. Our job is to find the arc length. And arc length equals radius times radians. So I have everything I need. I'll simply take 10 times 2.1, and the answer is 21. The length of that arc is 21 units. What angle measure describes southeast? Well, we remember that on a compass, northeast, southwest, this is 0 and this is 90 and this is 180 and this is 270. That is different than every other angle we draw. But this is navigation, it's using a compass, it's using directions, so this is the setup we have to use when that's the case. Now we want southeast. So southeast would be right smack dab in the middle of south and east. This is southeast. Now if it's right in the middle, then that means these two angles are 45s. So the measure of the angle we want is 90 plus 45. So it would be 135 degrees. So the measure of southeast is 135 degrees. Okay, now we we are given that the tangent of an angle is a third, and the angle is between 180 and 270. If we are between 180 and 270, what quadrant are we in? If we are between 180 and 270, we would have to be in which quadrant? Well, remember, this is not direction. This isn't northeast, south. This isn't navigation. This is simply a trigonometric angle. So this is 0, 90, 180, 270. I'm between 180 and 270, so I must be in quadrant 3, between 180 and 270, quadrant 3. The tangent is 1/3. Now notice there's no negatives in the problem, but I put negatives here. I put negatives here because I'm in quadrant 3. I'm going left and down. That means I have to be negative. -3, -1, opposite over adjacent. Now I'll do my Pythagorean theorem to find my hypotenuse. So 1 squared plus 3 squared equals r squared. 1 plus 9, so r squared is 10, and it looks like my hypotenuse or my radius must be √10. So using that now, I'm going to fill in all of these blanks. Now the tangent I already know, that was told in the problem. So similarly, cotangent I know. The reciprocal of 3, or 1/3, is 3/1. All right, here we go. What's my sine? Well, sine is opposite over hypotenuse, so that's going to be -1 over √10. Now, we don't like that, do we? Because it's got a radical in the bottom. So we'll rationalize it. We'll multiply top and bottom by √10, and we get -√10 over 10. Now, my cosecant is the reciprocal of my sine. Let's not flip this. That would be silly because then I'm going to have a radical on the bottom again. Let's flip it right here. Flip this right here. This is the answer to the problem for the sine. But I'm going to flip this one so that I have -√10 over 1, or -√10. Cosine. Adjacent over hypotenuse. Got the same issue I had before. I'm going to have to multiply the top and the bottom by √10 over 10. So I'll have -3√10 over 10. That's the answer. But this is what I'm going to flip. My secant will be -√10 over 3. Flip it here. These are the same number. You can flip it anywhere you want. And we already did the cotangent, so we're done. Moving on. Next, we're going to do a bunch of evaluating. We're going to evaluate the secant of 90 and the sine of 7 pi over 4. So the secant of 90 and the sine of 7 pi over 4. All right, so here we go. Secant 90. Uh-oh, 90 is a special one. 90 is right here. This is 90 degrees. It is on an axis. No triangle. No SOHCAHTOA. We need to figure out an x, a y, and an r value so that we can find the secant. So we decided we were going to let our radius be 1. If that's the case, then this point right here at 90 degrees, that point would be 0, 1. Straight up, 1 unit. So x is 0 and y is 1. Now I need the secant. So I need to remember that secant is reciprocal of cosine. Cosine is adjacent over hypotenuse. So the secant will be, it's adjacent over hypotenuse, but I don't have a triangle. So I have to think x over r. Cosine is x over r, which means secant will be r over x. So when I put my r value, over my x value, I can't sit on the egg, so I am undefined. The secant of 90 is undefined. the sine of 7 pi over 4. First thing I'm going to do, of course, is change that into a degree measure. 7 pi over 4. Pi is 180, divided by 4 is 45, times 7 is 315. Now, of course, I can do that faster than you. I'm the teacher and I'm old. Over to the side, 45 times 7. This is what you're going to do if you can't do it in your head, and you're going to get 315. Now we draw a picture of 315 degrees. Now remember, this is not navigation. This is a regular trigonometric angle. So where's 315? Right here. It's in between 270 and 360. This is 315. What's the distance? This is the angle I want. What's the distance between 360 and 315? It's 45 degrees. So I have a 1, and a root 2. And this one is negative. That one has to be negative because in quadrant 4, I'm going right and down. The sine is opposite over hypotenuse, so that will be negative 1 over root 2, which again, just like that problem, we have to rationalize. Negative root 2 over 2 is your answer. Got a couple more of these now. We're going to find the tangent of 2 pi over 3. So the first thing you're going to do, probably, is change your 2 pi over 3 into degrees. So here we go. The tangent of 2 pi over 3. Pi is 180, divided by 3 is 60, times 2 is 120. Remember, these are standard trigonometric angles, so 120 is going to be right here, in between 90 and 180. I need this angle. From 120 to 180 would be 60 degrees, so this is a root 3, this is a 1, this is a 2, and this time that one is negative because we're going left and up. I want the tangent. Tangent is opposite over adjacent. So that would be negative root 3 over 1 or negative root 3. Cosine, negative pi over 6. Negative pi over 6 would be negative 180 divided by 6, negative 30. Now how do we draw negative angles? We start the same place, but we go down. So we're going to go down 30 degrees. That's a 30-degree angle right there. I'm going down 30 degrees because of the negative. This would be a 1, 2, root 3. That's my 30, 60, 90 triangle. And that one would be negative because, again, I'm in quadrant 4, so I'm going right and down. I want the cosine. Cosine is adjacent over hypotenuse, so the answer is root 3 over 2. Now I'm going to use my calculator, so we'll get our calculators back out, and we're going to pay really close attention to the mode that we are in. Because some of these problems you can tell are degrees, and some of the problems are radians. So we have the cosine of 142.19, that's a degree, I'm going to mark it with a degree. We have the sine of 180, that's a degree. We have the tangent of 8 pi over 11, not a degree. Cosecant 311, degree. And cotangent 3, not a degree. This one you can tell is a radian measure because of the pi. This one you can tell is a radian measure because it does not have a degree symbol. So for these three problems, I'm going to do these three first because my calculator is already set in degrees. If yours isn't, set it that way. And we're going to type those in first. So to type this in, I type cosine 142. Then I'm going to go into my second angle menu. Remember, that's your apps button. We talked about that earlier. That's your second angle button. There's the degree mark. 19 into your angle menu again, click down 1 to get the minute mark. Yeah. And we end up then with an answer of negative 0.7914. Wait, this is round to the nearest thousandth? Yep, so I got to get rid of this 4. Negative 0.791. Next one, sine 180, that's easy. The sine of 180 is 0. Uh-oh, cosecant. How do I type that in? 1 divided by sine, that's exactly right. So I'm going to type in 1 divided by sine 311. And I get negative 1.325. Negative 1.325. Perfect. Now I'm going to go into radian mode. And I'm going to type the tangent of 8 pi divided by 11. The tangent of 8 pi divided by 11. Now, I did change my calculator into radians, and I am using my pi button, which is located over right under the clear button. So I end up with negative 1.154 as the tangent of 8 pi over 11. And then cotangent 3, well, this is just like the cosecant. I have to type 1 over the tangent of 3. 1 divided by tangent 3 is negative 7.015. Make sure I got those right when I did them before. Yep. Okay. If you're having trouble typing things in on your calculator, please do lean over and ask your neighbor. Okay, number 10, here we go. These are kind of tricky. I think we've been getting them a little bit better, but we'll try it again, just to make sure. We are solving between 0 and 360. We are cosine equals root 3 over 2, and tangent equals negative 1. Okay. Now, this right here, 0 to 360, tells me that my window of opportunity for answers is the entire circle. So I'm going to look around the entire circle for places where I might have a triangle that has a cosine of root 3 over 2. Notice that is a positive number. Cosines are positive in quadrant 1. How do I know that so definitively? Everything is positive in quadrant 1. Now, where else would the cosine be positive? Stop and think a minute. Cosine is x over r, or adjacent over hypotenuse. The cosine is going to be positive anywhere that x is positive. So not only are we going to be positive in quadrant 1, we're also going to be positive in quadrant 4. Now my picture's not too great. These two triangles are congruent, even though they don't look like it in my picture. They are the same triangle, just one's in quadrant 1 and one's in quadrant 4. Now the cosine is root 3 over 2, adjacent over hypotenuse, root 3 over 2. You're supposed to recognize that triangle. You need to be able to recognize that this is a 1 and this is a 30. The answers to the problem then are these two angles. This one right here, which is between 0 and 90, and that's a 30-degree angle, so that would be 30. It's pretty, I think, obvious for that one. And then this angle, which is between 270 and 360, and this is 30, so this right here is 30, so this must be 330, because it's 360 minus 30. So the two answers to the question are 30 degrees and 330 degrees. perfect. The next one, we're going to do exactly the same thing, but it says the tangent is -1. All right, so we got to stop and think about, where is the tangent negative? Now think about that. Tangent is y over x. If you want that to be negative, then one of these has to be negative. So we have one negative here and one negative here. Here we have two positives and here we have two negatives. If we want this fraction to be a -1, then we need one of those, either y or x, to be negative. Now the tangent is 1 over 1. We'll think of that as a fraction, 1 over 1. You need to be able to recognize that triangle. This would be √2 and this would be 45 degrees. Again, that's something you just need to be able to do. The answers to the question then are this angle, which is somewhere between 90 and 180, and this angle, which is somewhere between 270 and 360. All right, now look, you know this angle's 45. So 180 minus 45, this has to be 135 degrees. So one of our answers is 135 degrees. 180 minus 45. This one is down 45 from 360, so it must be 360 minus 45, which is 315. So the two answers to that problem are 135 and 315. Those are tough. You can do it. If you need to hear that explanation again, go back and rewatch that or the other review sheets video for those problems. Okay, we got a bird in the top of a tree. Here he is, the bird in the top of the tree. The tree's 18 feet tall. He spots a worm on the ground, so here's the bird looking at the worm. The bird's angle of depression is 28 degrees. Be careful. This is 28 degrees, which means this is 28 degrees. We have talked a lot about the fact that angles of depression and angles of elevation are the same. I'm going to put that 28 right down here so it's inside my triangle. How far is the bird from the worm? Okay, now be careful here. This is the bird, this is the worm. How far apart are they? This is x. This is not x. This is not the bird. This is the base of the tree. We want to know how far the worm is from the bird. That's x. So which function will I use? Here's my angle. This would be the opposite side and the hypotenuse. So we'll say sine 28 equals 18 over x. I can cross multiply here if I want and say x sine 28 equals 18. So x will equal 18 divided by the sine of 28, which I will type into my calculator, being very careful to make sure I am in degree mode. This is a degree measure, so make sure you're in degree mode. And I have 18 divided by sine 28. And that distance is 38.34 feet. 38.34 feet. Okay. Now I'm finding the the sine, S-I-G-N, that's positive, negative, or zero, of the following angles. I am not finding a number, I'm not finding a fraction or a decimal. I am just telling you if this is positive, negative, or zero. And I am not allowed to use a calculator. Okay, so I'm just going to pick one, positive, negative, or zero. Let's start with 395. Let's talk about 395. If I were to draw a picture of 395, if I went all the way around, that's only 360, isn't it? That's 360. So wouldn't I have to go 35 more? Wouldn't I actually have to go all the way around and then 35 more degrees? I would be in quadrant 1. If I went all the way around and then 35 more degrees, I'd be in quadrant 1. What do we know about everything in quadrant 1, kids? Sine, cosine, secant, tangent, everything in quadrant 1 is positive. So the cosine of 395 would be positive. If you are in quadrant 1, you are positive, period. Tangent, 11 pi over 12. Now, think about this for a second. You can change that into degrees if you want. Now remember, you do not have a calculator, so you'll have to do that arithmetic by yourself. But it's possible, and you certainly could do it. However, I think you could also think about this a little bit more logically. This is 0, and this is 180, which is pi. So this is half a pi, which is 90. This number is 11/12 pi. The fraction 11/12 is more than a half. 6/12 would be a half. So it's more than a half, but it's not a whole. So if it's more than a half, but less than a whole, it has to be in quadrant 2. More than 11/12 is more than a half, but less than a whole. So it's somewhere in between a half and a whole pi. In quadrant 2, we know x is negative and y is positive. We go left and up to build the triangle. So x is negative, y is positive. Tangent is y over x. So if you put a positive over a negative, y over x, positive over negative, you're going to get a negative answer. The tangent in quadrant 2 is negative. Finally, negative 100. Negative 100. Now remember, negative means go down. Here is negative 90. So we're going a little bit past negative 90. Negative 100 is a little bit past negative 90. So we are somewhere in quadrant 3. What do we know about points in quadrant 3? X is negative and y is negative. We're going left and down. Negative, negative. Cosecant is the reciprocal of the sine. Sine is y over r, so cosecant would be r over y. R is always positive. In quadrant 3, y is negative, so the cosecant of negative 100 would be a negative number. Okay, almost done. Doing great. Now we're going to do our sketching. So here we go. We're going to sketch this one and list its amplitude and period. And we're going to sketch this one and list its amplitude and period. And we're going to sketch one more and and list its amplitude and period. All right, here we go. Give myself a little bit of a reference here before I get started. I'm going to go ahead and just put my standard curves up here for my reference. That's a sine curve. And again, kids, you need to know this. This is your basic sine curve. You need to know it. This is my basic tangent curve. You need to know it. These are in your note sheets. They were the very first graphs we did, so you can always keep that note sheet by your side while you're doing your homework. Not going to have it on test or quiz. You're going to need to know it then. But while you're doing your homework, get your note sheets out, and the very first three we graphed were the basic functions. So now I have put on my paper for my reference the sine, cosine, and tangent curves. I'm going to be using those now to do my sketching. Okay, so look here what we've got for this first problem. We have a negative sign. That means I'm going to tip it upside down. And its amplitude is 3. This number multiplies the amplitude. The original amplitude is 1, so it's been times by 3, so now your hills and valleys are going up to 3 and down to -3. The period of all sine curves is supposed to be 2 pi. But we have put a coefficient in there that divides the period. So we have 2 pi divided by 1/2, which is 2 pi times 2 over 1, or 4 pi. That means that all of my labels have been doubled. I divided by 1/2, which is the same as timesing by 2. So instead of ending at 2 pi, I'm ending at 4 pi. Instead of the middle being pi, it's 2 pi. Instead of 1/2 pi, it's pi. And instead of 3/2 pi, it's 3 pi. All of these labels, these are the basic standard labels, are getting timesed by 2 because they were divided by 1/2. Divided by 1/2 is timesing by 2. Now we have a tangent. Tangents, remember, have an asymptote on either side of the origin. This is a regular tangent, positive, so it's going to sketch it in. There it is. Beautiful little tangent curve. Tangents do not have amplitude because they don't have any height. They go on forever and ever. They're not like the sine curve where they got hills and valleys. The period is supposed to be pi, but this one has been divided by 1/6. Remember, the period of the sine and cosine is 2 pi. The period of the tangent is pi. So we have our normal period, which is pi, then divided by 1/6. This number divides the period. So pi over 6 divided by 1/6, or excuse me, pi divided by 1/6 is pi times 6 over 1. My period is 6 pi. That does not mean this is 6 pi. No. It means all of the labels are getting timesed by 6. So when you take 1/2 times 6, you get -3 pi and +3 pi. The 6 comes in because that's the distance from -3 to +3. If you go backwards 3 and forwards 3, that's a total of 6. Backwards, forwards, 6. total of 6. 3 this way, 3 this way, total of 6. That's what period means. This is 6 pi. The asymptotes are at 3 pi. And finally, we have our handy-dandy cosine. It's a positive cosine. Positive cosines start at the top of the hill and end at the top of the hill. The amplitude has been times by a half, and there is no number here, groupies, so that means your period is still 2 pi, which means all of your labels stay the same. No change, because there's no number in there. So the period is still 2 pi. The amplitude is a fifth. So in reality, I certainly didn't draw it to scale. In reality, this curve has been squished. All right, good job. Have a great day.